This is Algebra 2 with trig, 7b.2. We're talking about series, and with summation notation, we're going to use formulas for calculating the sum of arithmetic and geometric series. To start out, we have our two main formulas right here, where n is your number of terms, a of 1 is your first term, a of n is your last term. Same thing down here. R would be your common ratio. So to notice, this one we need to know how the numbers change, but we do not need to know what the last term is. In this one, we need to know the last term, but we don't need to know the common difference. We don't need to know how the numbers change. So different formulas require different parts. So the sum of a finite arithmetic series. To find the sum of the first n terms, whichever amount that you want to add together, the n terms of a arithmetic sequence, is n a of 1 plus a of n divided by 2. It's the average of all the terms times the number of terms. So we come over here. What we need to know. First of all, are you convinced this is arithmetic? What makes this arithmetic? Because the rule here is linear. That's what makes it arithmetic. It's not because there's a plus in it, because there's different formulas that might have a plus in it. The main fact is that your exponent on your variable is to the first power. That makes it linear. This is a linear equation. It increases by 5 every time. So yes, we know it's arithmetic. Then if it's arithmetic, we need to know the number of terms. We need to know the first term, and we need to know the last term. Those are the things we need to know. How many terms, what is your n in this case? The number of terms is not 1. It is 20. Why is the number of terms 20? How do we know the number of terms is 20? And be careful on this, because I'm going to tell you you're probably not correct. It's not the number that's on top. It is 20. But for other problems, the answer is not 9. So it is not just because the number on top. It has to do with the numbers from 1 up to 20. And I'm trying to make a big point of this so we don't make the mistake later on thinking it's just the number written up on top. So if you plug in a 1 and a 2 and a 3 all the way up to 20, you plugged in 20 terms. But over here, if you plugged in a 3 and a 4 and a 5 up to 9, you did not plug in 9 terms.
20 is the number of the last term, like that's not how many terms there are.
By definition, the top number helps you determine your last term. Very good. So this would be 3 plus 5 times 20. That would be 3 plus 100, which is 103. Your first term is plugging in this bottom number. By plugging in the bottom number, we get 3 plus 5 times 1. That gives us 8. Now we know everything we need to. We know it's arithmetic because the rule is linear. We know what the number of terms, the first term and the last term are. So it would be good to call it the sum of 20 terms, but it's fine to call it S of n. I do it about half the time. We know the number of terms is 20, so n is still 20. A of 1 is 8, plus A of n, or the last term, which is the 20th term, A of 20, is 103. And we're dividing that using our formula by 2. Now we can calculate this a couple different ways. We could figure out that this is 111 divided by 2 and then times that by 20. That totally works. You can divide here by 2. That's 111. And then we know that when you multiply a number by 10, you put a 0 at the end. So we have 1,110. That would be the total sum of all of those values. What did we not have to do? We didn't have to do a lot of things. But one thing that's obvious that we didn't have to do is we didn't have to make a list of all the terms and add up all 20 terms together. That's what we did last night. Tonight we have a formula for arithmetic. It would work, but it's not necessary. We have a formula for it. In this one, we need to know this is arithmetic, that this is to the first power. Now we also need to know the number of terms. The first term, the last term, are the different parts of our formula. So looking up here, and this is a little tricky. A lot of people think it's the top value. We had this discussion earlier. But when you plug in a 3 and you plug in a 4, 5, 6, 7, 8, and 9, notice there are not 9 terms here. There are 7 terms here. 1, 2, 3, 4, 5, 6, 7. Including 3 up to 9. It's like all the numbers bigger than 2. Okay, you got 3, 4, 5, 6, 7, 8, 9. There are 7 terms. A of 1 is when you plug in the 3. Not plug in a 1, but when you plug in a 3. So this is 72 minus 18. That should be 54. Your last term is when you plug in a 9. That's 72 minus 54. 6 times 9, which is 54. 72 minus 54 would be 18. So our total sum of our 7 terms is the number of terms times the first term plus the last term divided by 2. That's 7 times 72 divided by 2. 7 times 36. If we have 36 times 7, that would be 42. 21 and 4 is 25, so 252 is the sum of our first 7 terms. Next, we're going to talk about geometric. In both these situations, these are finite. the list has a starting point and an ending point, which makes sense. So our formula is a of 1 minus r to the nth power, 1 minus r. So as before, it's as easy as following the formula. What we need to know. We need to know this is geometric. How do we know this is geometric? It has an exponent. That's probably a good start. Not just any exponent, but a variable is part of the exponent. Okay? Our explicit rule for geometric is in the same pattern. This is going to tell us a lot of information for this problem. So this is following the pattern of geometric. It has a term that's being repeated again and again and again by multiplication. That's what the exponent does to it, the variable of the exponent. So we need to know what the first term is. Well, the first term is going to be 4. It's going to be 4 for a couple reasons. One, because this rule is written in the format of our explicit formula. So we know that it's going to be 4. We could test it by plugging in the 1 into this rule, and it'd be 1 minus 1, which is 0. 3 to the 0 power. 3 to the 0 power is 1. So it's 4 times 1, which is 4. The r value is the value that's being repeated again and again. So that's 3. And n, which is the number of terms, starting with 1, as long as we're starting with 1, 16 is going to be our answer. So we're ready to plug it into our values. We have 16 terms we're finding the sum of. Our first term is 4. 1 minus 3 to the 16th power. 3 to the 16th power is going to be a pretty large number. Minus 1 times your ratio, or 1 minus the ratio. So this one will require a calculator, especially because 3 to the 16th power is not on our power chart. So we've got 4 times our parenthesis. Then we have our numerator. So we need another set of parentheses. 1 minus 3 to the 16th power. Then you need to close the parentheses, because that's your numerator, divided by the denominator, 1 minus 3, and close the parentheses. So that, in the calculator, is what it looks like from our formula. 860-93440. Bring in your commas, and then you can name it properly. 86,093,440. Kind of like your bank account. So, over here, looking at the next one. Doing the same thing. We need to know, first of all, that this is geometric. We know that the first term is 3. Notice the way the rule is written. The way that this could mess up or be a little bit different is if it was 2 to the I power. Or if this was actually n, it would be 2 to the n power. It wouldn't be n minus 1. it requires it to be n minus 1 if your leading coefficient is going to be your first term. If you're not sure, and that's too complicated, just plug the 1 in there and you'll be more familiar with what your first term is. So r is 2 because that's the value that's being repeated by the exponent. And n, since we're starting with 1, is going to be 5. Those are the parts you need to realize. So S of 5 is going to be the number of terms. Actually, the first term. The first term and 1 minus your ratio raised to the number of terms over 1 minus your ratio. So this is 3, and the 3 is timesing a numerator, so you need another set of parentheses. 1 minus your ratio raised to the number of terms. That's your full numerator. Your denominator is 1 minus your ratio. And we get 93. Now, for you to get credit for such answer, you need to show what you're plugging into your calculator. You need to show the formula filled in. And then from there, if we're going to use a calculator, we might as well use it correctly. For our next problem, look down at this story problem and try to determine what situation we're dealing with. Because once you know what to do, the math itself is not that tricky. But deciding what to do is the tricky part. So go ahead, pause the video, give this a look over, try to determine, is it arithmetic, is it geometric, what are your different terms you need to know. Then it's just a matter of plugging it in. So we have 24 seats in a theater that are in the front row. Each consecutive row has one more. So if we have one additional seat for every row, this is definitely arithmetic. Where D equals 1. So the formula we like to use is our explicit formula. So our rule, our first term we said was 24. That was the number of seats in the first row. We're adding one additional seat every time. N minus 1. So this is distribute, distribute. So we get N minus 1 plus 24 is going to be a positive 23. That is our rule. So if you needed to know how many were in the 30th row, so A of 30 is going to be 30 plus 23. That's going to be 53. So write a rule for the number. Well, we did that. A of n equals n plus 23. How many seats are there in the theater? Well, you need to know your formula. And our formula is n, a of 1 plus a of n over 2. Our number of terms, there are 30 different rows, so we know that n is going to be 30. Our first term was 24, and our last term is going to be 53. Now we're ready to add those all together. So the sum of our 30 rows is going to be 30 times 24 plus 53 over 2. That would be 77. We could divide the 13 or the 30 by the 2 to give us 15. And 77 times 15 is 1,115, or actually 55. 1,155 seats. All right, we'll flip it over. In 1999, about 586,000 used cars were sold in Maryland. Through a period of time, the number of used cars increased by 3.8% every year. Write a rule for the total number of cars sold. A rule for the number of cars. So, we know that this has a percentage in it. That means this is changing by a percentage every time. This is going to be geometric. So if it's geometric, it's going to be A of 1 times R, n minus 1. We know that we're starting with 586,000 cars. We don't have to have the zeros. It's just our final answer will be in thousands. Our ratio, how it's changing every time. You got to be careful. First of all, you need to move the decimal spot over 2. Some people have made a mistake in the past and they're using the wrong decimal version. The second part is, are we looking for the cars to be at this amount and increase by 3.8%, or are we decreasing by 3.8%? We're increasing by 3.8%. So 1.038. We add together the 1 plus the amount that they're changing by to the n minus 1. That would be our rule. Write a rule. What was the total number of cars sold between this time? Well, first of all, you need to know what your rule or your formula is. So you know what parts that you need to know. We need to know the number of cars they're starting with, and that was 586,000. We need to know the ratio at which these are changing by. Our ratio is going to be 0.038. And the number of terms from 1999 to 2004, there are a 5-year span in there. So we're ready to calculate our 5 numbers together. So our first term is 586 divided by 1 minus 0.038 to the power of 5 over 1 minus 0.038. So you first have to write out your formula, plug in all your numbers, then you can go to your calculator. You start out with 586,000, then you use a parenthesis because you're timesing it. Then you have a numerator, so you need another set of parentheses. 1 minus 0.038 to the power of 5. We don't have to have parentheses around that. You could if you wanted to. So then I close the parentheses around my numerator, and I divide that by 1 minus 0.038. I can close it off if I care to. That gives us 609. You could get detailed if you wanted to. 1/5 thousandths. So 609, 147.56 if you were really thinking about the cars. That's how many there'd be. But this is just fine. 609. All right, last one here. Find the sum. What do we have? Looks like we're going up by 5, then we're going up by 5. This is arithmetic with D equals 5. How many terms are there going to be to get up to 35? Well, if you use your formula, right, we need to know, to find the sum, let's think about that for a moment. We need to know the number of terms times the first term and the last term divided by 2. That's what we need to know. We don't know what the number of terms is. Our first term is -1. Our last term is going to be 34. Those are the easy ones. What we don't know is the number of terms. So we use our formula to be 34. Start with -1. Our common difference we determined was 5 with n minus 1. So that would be -6. Add it across to get 40. And we get 8 terms. There are 8 terms in this list. One way we could test that is to start with 34 and subtract our 5 each time. So that would be our last term. So 1, 2, 3, 4, 5, 6, 7, and our 8th term. So that does make sense. So we're finding 8 different terms. So 8 times -1 plus 34 divided by 2. We can reduce here if we wish. 4 times 33. 33 times 4 would be 12. 12 and the carry the 1 is 132. So again, notice how this is different from yesterday. We did not need to find out every term and add it together.